All right, so, excuse me, the next day, here's what we're going to do. We're going to evaluate some trig functions using our unit circles. So we're going to specifically be able to do this no calculator with your unit circle. So you can use either the one you made or the one that is at the beginning of your packet that you could have filled out, okay? So make sure you have that in hand. So cosine, sine, cosine, and tangent are not the only trig functions. So those might have been the only ones you have used in the past. So there are actually 6 altogether. We have sine, cosine, tangent, and cosecant, secant, and cotangent. Instead of me writing this down and you watching it, I'm just going to show you the notes and then I'll explain. Okay. So right there. Okay, so we've known sine in the past as opposite over hypotenuse, right? When we do right triangle. Cosine as adjacent over hypotenuse, and tangent as opposite over adjacent. And if you really want to think about it, especially when we use our unit circle, because we have sine and cosine on that, tangent is sine over cosine. Okay, so we can find tangent on the unit circle by taking our y value. Yes, our y value, which is our sine, all over our x value, which is our cosine. So that's how we can do tangent on the unit circle. But we can do the other 3 also with our unit circle. Cosecant is hypotenuse over opposite. It's the reciprocal of sine. So flipping that fraction, or 1 over sine. Secant is hypotenuse over adjacent, which is the reciprocal of cosine. So taking the cosine fraction and flipping it. And cotangent is adjacent over opposite, which is the reciprocal of tangent. And we can also think about that as flipping the sine over cosine to cosine over sine. Okay, so this will help us indicate our values on our unit circle of what we're trying to find. Of course, I'm going to move forward. If you are still writing, pause the video and write it down. All right, so we're going to use our unit circle to find the exact value. Now, of course, I'm going to go back and forth because I have my one that we put together. So secant pi over 3. So the first thing I'm going to do is find pi over 3, which I see is right here. Secant is 1 over cosine. So what I'm going to do is remind myself that this is 1 over cosine. Okay. So in other words, when we're looking at our unit circle and we're looking at our coordinate pair, our first point in our coordinate pair is our cosine. So cosine at pi over 3 is 1/2. Well, we need the reciprocal of cosine. So we flip that fraction of 1/2 and what do we get? The value of 2. We're done. That's how we can use our unit circle. Okay, cotangent of 330. Let's put this in terms that we know from our notes above. Our notes above said that cotangent was cosine over sine. And of course, we're doing this at 330. So what we're going to do is find our 330 on our unit circle. And I see it's right over there. Okay. Now, I'm going to write my fractions in their place. Cosine, of course, is our first coordinate. So we get square root of 3 over 2 all over. And then sine at 330 is negative 1/2. Okay. Now, of course, we're going to reduce this. So these twos, because watch, I'm going to show you. I'm going to show you mathematically how they cancel out or simplify more, right? Because any time that you divide by a fraction, it's the same thing as multiplying by its reciprocal, that flipping. And what happens there? Twos cancel or reduce to 1, and we're left with negative square root of 3 over 1, which is just negative square root of 3. Okay. So even though we were dealing with secant and cotangent, we're still able to use these unit circles to be able to help us figure out the exact answer. Now we can see a little bit of a pattern here. Notice in the unit circle that cosine is the same in quadrants 1 and 2 and 3, right? Cosine is the same and 1 and 4 and 2 and 3, right? Your coordinate pairs, right? Okay. So what that means is that cosine of negative theta, remember we talked about negative theta made us go counterclockwise, or clockwise, I mean clockwise, equals just cosine theta. That's great. Making cosine an even function. Sine is the same in quadrants 1 and 2 and 3 and 4, which means that sine of negative theta is the same thing as negative sine theta. That makes it an odd function. So let's see what that tells us. So we're going to do sine and cosine. So sine of negative pi over 3. We can think of this and go clockwise and find that value, or you can look at your unit circle, look at pi over 3, and at pi over 3, we have, well, actually, let's revert this back. So sine of negative theta is the same thing as negative sine of theta, theta being in this case pi over 3. So what's sine pi over 3? If you look at your unit circle, I'm not going to show you, look at your unit circle, pi over 3, sine is the square root of 3 over 2, and there's a negative in front of it. And there we go. So we can either go clockwise to find that negative pi over 3, or we can relate it to a negative sine of theta. Okay, let's do cosine. So cosine of negative pi over 3, it should be the same value as cosine of theta, which is in this case pi over 3. So all we have to do now is go to cosine pi over 3, and that pi over 3 cosine is 1/2, and we're done. Okay, so there's some symmetry to that periodically. So also notice that we can keep rotating around the circle, right? Once around the circle is 2 pi or 360. But do we have to stop there? No, we can keep going and going and going. So what we're going to do now is look at some of those evaluation of trig functions, not only just in one rotation, but multiple rotations of the unit circle. Okay, so let's go through some of these examples. Grab your unit circle, and we're doing sine pi, or 5 pi, right? So a couple ways we can do this. We can either go around the circle multiple times, we can subtract a full circle. I'm going to go around the circle multiple times, and we'll go from there first. So 5 pi. Start at 0. This is 1 pi, 2 pi, 3 pi, 4 pi, 5 pi. So 5 pi is in the same position as pi. So if we look at our coordinate pair here, now our coordinate pair, of course, is -1, 0. But we're looking for sine. Sine is our second part of our coordinate pair. So that means sine of 5 pi is 0. If you want to keep note, you could say that sine 5 pi is the same as sine pi, just to keep note to yourself. Okay, sine 480. The grades are a little bit different. They get confusing sometimes when you go around and around and around. So what I like to do is, here's where I might take out a full circle. So 480 minus 360, and I'm going to subtract a full circle, and I get 120. So sine of 480 is in the same spot as sine of 120. So when I look for sine of 120, which is, here is 120, and sine is the second part of the coordinate, So our answer is square root of 3 over 2. All right, now we're going clockwise. So let's remember to go clockwise. I'm going to put a little note to myself. Grab your unit circle. Okay, now if you want to compare, you could say, look, by going to 60 degrees normal, we're going this big jump. We're going to the peak, right? We're going here. So we're doing the same thing, but we're going to go opposite, right? So if we go opposite, we're right here, and we're looking for sine again, and sine is negative square root of 3 over 2. Now, the other thing you could have done is go back to the symmetry, and remember, sine of negative theta is the same thing as negative sine of that theta. So you could have done that also and said, hey, sine of 60 is here, but it's negative of that. So there's a couple ways. All right, radians. Couple of things. One way that you could do this is this. You see this 13 pi over 6. So you could go pi over 6 is your 30 angles, 30 degree angles. So you could go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we're back at our pi over 6. Sorry, I meant to put this thing in. Or you could do what we did above by subtracting a full circle. Now, a full circle is subtracting 2 pi, right? 2 pi, but over 6, right, is 12 pi over 6. Okay, so I'm subtracting a full circle. When I subtract a full circle, I'm left with 1 pi over 6. So I know I'm finding cosine pi over 6. And when you know, that's where we belong, right? That's what, so you can either count or you could subtract your full circles. So we're looking for cosine. Cosine is the first coordinate. So our answer is square root of 3 over 2. All right, cosine of 225. There's nothing to subtract here because 225 is on our unit circle. But if I look, because I'm using this one instead of the one you guys wrote in your packet, 225 is one of our 45s. So 225 is down here. And we're finding cosine. So cosine is our first coordinate. So that's negative square root of 2 over 2. That was very basic, right? Just find it on your unit circle. No manipulation needed. All right, cosine of negative 5 pi over 4. This is where I like the symmetry, right? Because we know that cosine of negative theta is the same thing as cosine theta. Which is kind of awesome, right? Because now I can just look at 5 pi over 4, which is actually right here, and cosine of 5 pi over 4 is negative square root of 2 over 2. Now I'm going to show you how to do that the long ways if you wanted. Okay. Remember, since it's negative, we're going backwards. Or clockwise. So 1, 2, 3, 4, 5. Yes, we're in a different spot, but as you can see, our cosine is still negative square root of 2 over 2. That's the idea about the symmetry stuff, okay? Tangent of 720. So we got two things to keep in mind. 720 is more than 360, right? So we have to subtract our full-on rotation. And we have to think of tangent as sine over cosine, okay? So let's reduce our full circles. So if we subtract 360, we get 360. Subtract 360 again, and what do you know? We're at 0. So we're finding tangent 0. And I'm going to rewrite this for your notes. When we find tangent 0, what we're actually finding is sine of 0 over cosine 0. Okay? So take your unit circle. Okay, right here, we're at 0. This coordinate, of course, is 1, 0. So sine of 0 is 0. Cosine of 0 is 1. So we're going to have 0 over 1, which we know is 0. Okay. Tangent pi over 4. Great. Pi over 4 is exactly one rotation on our in one rotation on our unit circle. But we have to keep in mind we're finding sine pi over 4 over cosine pi over 4. Okay, grab your unit circle. Pi over 4 is right there. Sine and cosine are both square root of 2 over 2. Square root of 2 over 2. And of course, we know anything over itself is reduced to 1. Perfect. Okay, this one's getting a little bit trickier, right? Because we didn't do a symmetry with tangent. So don't go the symmetry route. We're going to go backwards 270 degrees. And again, I say backwards, but I really mean clockwise. Okay, so 270, and I guess I can be on this one. Okay, start at 0. So I go negative 90, negative 180, negative 270. So negative 270 is the same thing as 90. Okay, so we're really looking at tangent 90. Do you guys see why I say tangent 90? Okay, let's change it into a sine of 90 over cosine 90. Okay, let's look at our coordinate pair again. Okay, up here we're at 0, 1. So sine is 1, cosine is 0. So sine is 1, cosine 0. Can we divide anything by 0? No. So it's undefined or does not exist. Okay. Then for the last one, cosecant. Cosecant is the reciprocal of 1 over sine. Right? There we go. I should say the reciprocal of sine, so it's 1 over sine. And 5 pi over 3 is on the unit circle, right? So let's find 5 pi over 3 in the unit circle right here. Okay? So we're looking for sine, right? So look at sine, and we get negative square root of 3 over 2. So really, we're looking at 1 over negative square root of 3 over 2. And we know dividing by a fraction is the same thing as multiplying by its reciprocal. Okay. Now, I know we were always taught in the past never to keep square roots under the denominator, but check to see if your assignment allows this. And if it does, you're all set to keep it like this because further math, they don't mind with the simplifying. But if you have to simplify, to get rid of the square root in the bottom, we have to multiply it by itself. And whatever we multiply the top by, we multiply, or the bottom by, we multiply by the top. So when we do that, we get negative 2, square root of 3, all over. Well, the square root of 3 times the square root of 3 is the square root of 9. What's the square root of 9? 3. And we're done. Now, of course, these are just, we try to cover as many tricks as possible with the unit circle. Do not use your calculator. Every answer that you can get can be found on the unit circle. You just might have to manipulate it a little bit more. All right, try that out.